Hi. Hi everyone. I hope I'm visible and audible now. If there are any problems, you don't see. I hope you all see slides. If don't, please add some comments. Um, okay, so let me start. My name is Elena Novikova. I work for EY. And today I'd like to talk about unit testing, about test-driven development approach, and I will show how we can use test-driven development approach for a real application. In this presentation, I will cover only testing of some basic functional requirements, and I will not talk about Spring transactions, multi-threading, concurrent access to the database, and other advanced topics. I will conduct presentation in English, as you noticed already, but I also speak Polish, so you can ask questions in Polish if needed. Okay, so let's start. All of us know that as programmers, we should test our code to make sure that it works correctly. Usually developers prepare unit tests. So what is the definition of the unit testing? Unit testing is a software testing method by which individual units of source code are tested to determine whether they are fit for use or not. How do we understand if our unit works correctly? We execute our unit and compare results of execution with the expected results. What are the purposes of unit testing? First purpose is to detect bugs at the development stage and decrease its cost. So as we know, the cost of um, the cost of fixing a bug at different stages of product life cycle is different. The earlier a defect is detected, the lower will be the cost of its correction. The second purpose of unit testing is to check that new changes don't disrupt the behavior of existing code. And the third purpose is to create living documentation for the product. So when there are unit tests presented for the product, some developer can check the tests and understand the main logic of the unit. Okay, let me also mention mocking, as it is an important part of unit testing. So mocking is a way to replace a dependency in a unit under test with the stand-in. So here is a dependency, here is our mock as a stand-in. Mocking allows to isolate the code being tested and not focus on the behavior or state of external dependencies. And we can, of course, control behavior of these replacement objects and program what behavior they will show or which state these stand-in objects will have. Okay. So I think that what I was talking before is clear and sounds reasonable. But in real projects, I have seen different problems related to unit tests. And let's talk about this using an example. So especially for the presentation, I have prepared a small 3-layer Spring Boot application called Price Service. Of course, it's not part of a real software product, but it is inspired by some real-life examples. This service is responsible for storing the information about prices of orders. Orders can be created by clients of bank to buy some banking product. Here is a sequence diagram representing logic of our price service. When front-end send GET request to retrieve information about order price, service will return 404 error, as there is no information about price in the database yet. To get information about price, front-end should provide order ID as a parameter. If there is no information about price yet, front-end will send a post request containing order ID, ID of banking product to buy, and quantity the client wants to purchase. To get information about price, our service will request this price from some external service. This request should contain order ID, desired quantity, unique request ID, and a time until which we will wait for the response to this request. And also it is a time until which we cannot send new request to external service. This parameter called request valid until. And also what is important, this parameter should be provided as date time in UTC time zone, and it should have predefined format, which is different from standard ISO format. And you can see the example of this external request in the bottom right corner. Right, you can see that request valid until field has some specific format. So this external price service will calculate the price of order based on provided product ID and quantity and some sophisticated algorithms which are not important for us. External service will not return price synchronously. It will just return OK response. And later it will return price information calling our endpoint with put request. You can see it at the bottom of the sequence diagram. There is a put request. External price service is often overloaded, and it is possible that it will not provide price information in reasonable time. That's why we are allowed to send new request for same order ID, but we should do it only after some time, called request time to leave. We see it on the left side of sequence diagram. Before we send a request, yeah, so we can send a new request only after expiration of this timeout. Also, before we send request to external service, we should create a database entity containing the information about request sent. It will be order ID, product ID, request valid until, and status requested. So in the top right corner, you see example of information stored in price service. It can have multiple fields. So for the case when we just send request, we will have status requested field, quantity, product ID, order ID, and also request valid until. Fields price valid until and price itself, these fields will be populated only with the response from external service. Yeah. Then if we receive a post request, when we receive a new post request from front-end until request timeout expired, we can see it on the sequence diagram. We don't send any external request. We will just return information that price was requested. It means that we will return price DTO with status requested and all other information stored in the database. If we receive GET request, we return information stored in the database for provided order ID. After timeout expired, we can send new post request to external service when we receive post request from front end. And also when external service call our endpoint with put request, we update our price entity with provided price, with time until which this price is valid, and we set the status of the price as current. And also we won't be able to send new post requests to external service. I mean, we not we should not send any new post requests to external service until current price is valid, right? So until price valid until field is the date in future. So I hope these requirements are more or less clear, because I will work with this further. So if it's possible, give some reactions, maybe some comments that it is clear. And I would ask to switch to code. Okay. So let me share my project. Okay, so having these requirements, first of all, I have defined it, and I have defined open API specification for our price service. For the sake of brevity, here it has only two endpoints, only get and post. And also based on this open API specification, I generated code using Open API generator. It generates for me API classes and DTO classes. As part of API, so we have this so-called price API delegate, which will process our requests, in fact. So it has a get price method for get requests, and request price method for post requests from front end. So here we can see price, get price by order ID. There is an operation ID get price, and here we have post price, and here is the operation ID called request price. So same as here, request price and get price. And of course, I have added implementation of this delegate and some services. We have price service containing the main logic. We have a repository for our database entities. We have also REST template to send external requests. Also, we have a date time conversion service, which is responsible for converting our local date time to date time in UTC time zone and in a specified format, right? Okay. And also, except of this, we have a mapper, which will map our price entities to external requests. Okay, as usually, so first we do implementation, and after that we add our unit tests. And exactly on this stage we can do something wrong. So could you please switch to slides again? Okay, thank you. So first Okay, let me maybe mention all problems, and after that I will show it in code. So first problem is that often developers write class tests instead of unit tests. So I will show it a bit later. In my example, I have separate price service test, separate datetime conversion test, and separate delegate test. In this case, in fact, we check a logic of each of these classes separately instead of checking logic of the whole unit. Also, we have problems with mocking static method calls. I also will show a bit later. And we have too many mocks and argument captors. And in fact, because of problems with static methods mocking and this Makita mocks and argument captors, we often cannot check all results of tested code execution. And it will, because of all these four problems, we cannot rely on our tests really. And when we introduce new functionality or do refactoring, even if code coverage is high, we still can have, let's say, problems in future. We'll have some bugs. Okay, so please switch to code. Okay, great, thanks. So here, as I have said already, we have separate tests, like tests per class. Also, if we are talking about problems with mocking static methods, I will show it. Yep. Yeah, for example, here, right? We have here we have static method call. It is needed to set a unique request ID. So we can call random UUID. And also here, when we calculate a time until which request is valid, we will call static method local datetime now. And we also will have problem with mocking of this method. In fact, we are not able to mock it, right? As you know, static methods. You cannot mock static methods. And also we have multiple mocks and argument captors in our test. So for example, in price service test, we have mock for repository, we have mock for REST template, we have mock even for our own datetime conversion service, because of these problems with static methods, we cannot use it normally here and check results. And yeah, as a result of these three problems, we will not have an ability to check all results of our code, right? So for example, here I have a test which will check that in case if we don't have any information about price yet, we will create a new price entity in the database. We will send external request and return some expected response, right? Here, in fact, we'd like to check our results, right? One of our results here will be a saved price entity. And of course, we'd like to check what will be the request valid until value, right? For what we sent. So we won't be able to check it because the value of this field is dependent on a static method call, which we are not able to mock. So we cannot, in fact, predict the expected result, right? We don't have expected result here. So if I run this test, it will fail. And the same situation with expected, yeah, you see, it failed. We try to compare this valid until times, and it is slightly different. And also we have the same problem for expected external request. So here this external request captor allows us to get the value of request sent. And if we'd like to check what was the request ID, we also will not be able to check it because because this request ID value is produced by UUID, random UUID. So we also don't have proper expected value here, right? So for example, if I comment this and try to rerun the test, it also will fail on this line. Let's check. So yeah, it failed. So because values, because we don't know an expected value, we can put only a random value here, and of course it will not pass. So as you know, code coverage is used as one of, let's say, quality gates for code. And in theory, if your code coverage is high, you can, just a sec. If your code coverage is high, you can, let's say, assume that your tests are reliable. And if you have done some changes, all tests passed, you will think that, okay, you have not broken any existing logic, right? So let's check what will be the situation with our example service. Okay, we can see that we have 13 tests, all tests passed. We have, I would say, quite high code coverage, right? Okay, so we can assume that our tests are reliable, but let's check if it is true, in fact. So I will try to break existing logic, and we'll see what will happen. Okay, I have broken existing logic. Let me rerun our tests. What do you think? Will it pass? I think it will. Okay, great. So you see, I have broken existing logic, but our tests still pass. What does it mean? In fact, it means that we cannot rely on our tests. And even if we break something, our tests probably will not indicate it. This is not good anyway. So yeah, please switch to slides. Thanks. Okay, so yeah, as I said, sometimes we cannot rely on our tests. So what can be the approach to solve this problem? So we can apply test-driven development approach. What is the main idea of test-driven development? So we take one of the requirements. We think about requirement. What are the state of external dependencies? What will be the input for our unit under test? What results our code should generate, and so on. And based on these assumptions, we create failing test. We create failing test. Failing because we have just described the requirement, but we haven't add any implementation of this requirement yet. And after that, we add implementation. which make this test pass. Here it is important to mention that we should add only code enough to pass the test and no more. And after that, we can do refactoring if needed and check that all tests pass again after refactoring. And then we can add new requirement, write new failing test, and repeat the cycle. Okay, so let me quickly review the test structure. So each test consist should consist of 3 parts. First part is given. Here we provide some, let's say, conditions for our test. It can be entities existing in the database. It can be some received HTTP request. It can be message received from messaging systems like, I don't know, Kafka, JMS, and so on. Next, we have part called when. This is the place where we actually call our code under test, where we execute code under test. And the third part is then. This part is needed to check the results of execution of our code. So what we can check? We can check entities saved or updated in the database. We can check what requests was sent outside to some external services. Also, we can check messages sent to messaging systems and so on. And another important thing related to our tests, what do we mock? So we definitely mock interactions with the database. We mock some REST interactions or something similar. We mock interactions with messaging system, and we also mock static method calls. I mean some calls like current date and time, random number generation, or similar. And in my opinion, it is better to use some custom mocks instead of Makita because it gives us more control and more ability to check our results properly. Okay, so let's switch to code, please. Okay, thanks. Okay, yeah, let me show how we can use test-driven development approach for development of the same price service. So here I use the same open API specification with 2 endpoints, same as for previous project. Again, we have generated DTOs and generated delegate. And also at the beginning, I have added price delegate implementation, but it is empty for now because I will add any implementation only to pass my test, right? Okay, so let me start with the first. Let me start with my test. So first of all, I will have only one test class. It will represent the tests for the whole unit, not for separate classes. So here I will add, first I will add only one requirement. It tells that if we receive get a request and we have some price information in the database, we should return this information to the front end. After that, I have added a test representing this requirement. So here we have given section where we create existing price entity. We save it to the repository. This existing price is represented as a JSON, so we read an entity from JSON. I prefer this approach in comparison with generating your, let's say, inputs in code, because it is human readable. You can just open file and you will see what was added to the database or what was sent and so on. So, okay, I have created from file. It is done, used, just we read the file and just use object mapper. Okay, so I have saved some existing price to repository. After that, I call my endpoint, and after that, I check results. We have two results. It is HTTP status, okay, and some DTO returned. DTO is also represented as a JSON file. So currently, our test is not compiled even because we don't have any implementation of repository yet. So let me go to the next step. Okay. So on the next step, I will add price repository, and also I will add some implementation to our price delegate. Okay, it is loading. So yeah, great. Okay, so what I have done here, I have added price repository. As you can see, it is just a pure Java interface without any annotations. We have two methods here. We have save method and find by order ID method. And also I have added my custom mock for this repository. It also has, of course, two same methods. When we do save, we just add the price to some list. And when we call find by order ID, we just search in the same list. Fair enough. And also I have added some implementation of this logic into price delegate. So here we search in a repository and return the result, if any. Okay, great. So let's check if our test pass. I think it will pass, as we have implemented the requirement. Okay, we can see that it passed. It means that now it's time to add new requirements and new failing tests. So for the sake of brevity, I will skip many steps. And now I will show the moment when I have already added second requirement and implementation for this. And so I have two passed tests. And after that, I have third requirement, which will not pass yet. Okay, so what do we have here? As I have said, we have second requirement, which is quite simple. When we receive get request and don't have any information in the database, we will just return not found method. So here the test is pretty simple. We just call our endpoint and just check that not found status is returned. And also implementation is also pretty simple. We have just added here a condition to check. Okay, great. After that, we have added the third requirement. It also is not, you see, this test is not compiled. So third requirement tells us that when we receive post request and there is no price entity yet for provided order ID, our service should do the following things. First, it should create new price entity with status requested, with unique request ID, and the field called request valid until, with some value in future, which is calculated like current time, plus predefined timeout, which is our request time to leave timeout. After this entity is created, it should be saved to the database, and also our service should send price request in provided format to external service. What is important that in this request valid until should have a proper format and should be same date but in UTC time zone. And of course, we should return information about what is the price entity we have just saved. So what we have in our test representing this requirement. So I create a request, I send the request, and after that I check results. So here I should check that we have sent a request to external endpoint, to external service. Here I don't have this external price service yet, which is this external price service is just a wrapper for sending a request using REST template. Also, I don't yet have an EDTO representing external request. So that's why our test is not compiled. And also, when we are talking about this external request, I use the same approach. It is represented as a JSON file. Okay, so let me go to the next step when I have added implementation for this to pass the test. Here, what is important, as you can see, I have created, for example, expected external request. I have created a JSON file which contains all fields and also this request valid until, which is dependent on current date and time, and request ID, which should be a UUID. And I will show how it is possible, right, to do this. Yeah, and what is important, so I read this expected request and check it as a whole, right? So I don't assert, sorry, no, not this. Yeah, here it is. I check the whole request, right? I don't check only specific fields, as I have done with assertions in previous example. Okay, so what I have added? I have added external price DTO. Also, I have added external price itself. So here is external price service. It has only one method called send external price request. And of course, I have added a mock for it, which override same method, send external price request, and also it has get sent request, which allow us to check what was the request sent, right? So here this send external price request. It is a very simple implementation. We just we just save the send request into some variable, and after that we return the value of this variable. Also, I have added some implementation into price delegate to pass this test. What we can see here. So yeah, here, how do we set a request ID, for example? To get this random UUID, I have added UUID provider. this like production, let's say implementation, it should just call random UUID. But we are interested in the mock, right? This mock will just return us a constant. So in general, to mock some static methods, we should just use these methods like with we should let's say to call some static methods in your code, you should first rope your static method call with some service method. Okay, and I have done the same for this request valid until. I have roped the call of the call get current local datetime with datetime provider, and I have added a test implementation for it. It will just return us some constant. So that's why we are able to check our external request sent as a whole request, and same with saved database entity. Okay, so let's run our test. So I think it will, all tests will pass, as we have implemented all requirements we have introduced, and it will be here, yeah, you see all tests passed. So here I will skip some intermediate let's say steps where I will add more and more requirements, and I will go to the moment where we have all tests added, all tests, all implementation added, and we will have the situation when all tests passed. So in general here, I will have 7 requirements and 7 tests added. Okay, this. So let's wait until until checkout is done. Okay, so as I said, here we can see previous 3 requirements. Also, I have added 4 more requirements. So fourth requirement tells us that when we receive a post request and there is price entity already in the database and it has status current and price valid until is in future, which in fact means that external service already returns us information about price, and this price is not outdated yet. So in this case, we will just return information about existing price, and we will return status OK. And we will not send anything to external service, and we will not save or update anything in the database. So let's maybe find this first test. Okay, here it is. So it tells us the same, what I have already told. Here, what is the difference here? So for example, here we have the check external price request not sent. So here we send that, okay, no requests sent. It means that here this request is equal to, sent request is equal to null. So nothing was sent. And also here we check that our executing of our code, our repository will contain only the price entity existing before the call, right? And also we have few more requirements. So for example, fifth tells us that, okay, when post request received and there is no price when post request receive and there is a price entity for provided order ID with status current, but price valid until is in the past. So we have some price from external service, but it is outdated already. In this case, we create a new database entity, we save it to the database, we send external price request and so on. Also, we have two more requirements. 6 tells us that when we have price entity and it has status requested and request valid until is in future, which means in fact that we just send request to external service. We have not yet received any response, but we are not allowed yet to send new request. So in this case, we just like do nothing, just return information existing in the database. And 7th, for the case when we have entity with requested status, but it is outdated already. Okay, so I have run the test. Let's check if it pass. If all tests pass. Okay, tests passed. So what do we have now? We have all requirements implemented. We have all tests passed. So probably we can improve our code. Okay, so I'm checking price service now, which contains main logic. It doesn't look really good as we have multiple nested ifs here. Also, we have some code duplication. So here I would like to first create a separate method for duplicated code. And also I would like to apply strategy design pattern because I see in general, I see 3 approaches here. One approach is for the situation when we have no price in database yet, so no information about price at all, no request sent. Second strategy will be for the case when we have some price with some price information with current status or requested status, and it is not outdated yet. So price is not outdated or request is not outdated yet. In this case, we do nothing, just return what we have. And third case is when we have something in the database, but this price info is outdated. It is either outdated price or outdated request. Okay, so let's go to the next step and I will show this result of applying these strategies. Okay. What I will show, I will refactor this price service. It will just contains, okay, we have it. It just contains now list of price strategies. So here we we go through this list, check if strategy is applicable, and if it is applicable, we apply this strategy. Price strategy is just an abstract class with 2 abstract methods, is applicable and apply strategy. So is applicable tells us if we should apply this strategy or not, and apply strategy method will just do all processing. So as I have already told, we have 3 possible strategies. So we have no existing price strategy when nothing exists in the database yet. We have existing outdated price strategy, and third one is existing valid price strategy. So after this refactoring, I of course should check if all tests will pass. So what do you think? If my tests will pass or not? I hope it will. So let's check. Okay, we see that all tests passed. I have run tests with code coverage, so we also can see that code coverage is quite high. So one of advantages is that, test-driven development will provide high code coverage out of the box. And let's check if our tests are reliable. I will do the same exercise I have done with previous project. Let me break existing logic and check what will be the result of it. So for example, let me comment here something. So I have broken existing logic. Let me rerun tests. In theory, if our tests are reliable, they should fail in case if we break existing logic. So yeah, we can see that 3 tests failed when logic was broken by me. And let's maybe do the same with some other place. For example, here. I guess, yeah, here I returned as it was. And in theory, our tests should fail once again. Let's check. Okay, yeah, so it fails. Please check to please switch to slides. I have final one. Okay, so as we have seen, using test-driven development approach, we can have unit tests which are reliable. It will allows us to safely do our changes and not be afraid that we will break existing logic. So let me summarize what are the test-driven development advantages. So in my opinion, we will have fewer bugs when we apply this approach. Also, we will write only the code which is really needed. We will have high code coverage right out of the box. Also, we can do refactoring safely. We will have really nice living documentation because if you use, for example, JSON files as inputs and outputs, it is easy to read and very convenient for developers. And you will just have better code, which is easier to maintain. So that's all from my side. If you have any questions, please. Do you use test-driven development in your organization in all your projects? I don't think so, especially because our organization is very big and I even don't know what is really used in other projects. But I would like to say that when I entered a current project, especially I usually try to apply test-driven development approach. So for example, even if you are not able to apply test-driven development for the whole project because you already have many tests implemented by other people, you can start with some new features. I have, for example, in current project, I have done this, right? So I have some big new feature and I implemented it using test-driven development approach. Next, please. Okay. What training did you attend with test-driven development? Does the company provide them for you? I work for EY only for maybe, I don't know, like how many? 4 months. So I have used to apply test-driven development approach even before I started working in EY. And in fact, I haven't have any, let's say, special training to learn it. but I just, let's say, read something about test-driven development approach, because there is, at least this Martin Fowler original book about test-driven development approach. There are many, let's say, information on YouTube, also articles and so on. And for example, in my previous organization, we have very nice experience with one of my colleagues when we implemented just a whole service from scratch using this approach. It was very nice experience. Is not test-driven development just a myth that everyone likes and hardly anyone will take advantage of? Well, I don't think it is a myth. I think it is one of approaches you can use, right? It is not a silver bullet, but I think it has many advantages, really. At least you will think more about your requirements, and probably you even will, let's say, ask for better requirements if these requirements are not clear enough. And you definitely will create tests which really check the behavior of your application, right? So you will be sure that your application really does what is required, right? So I don't think that hardly anyone will take advantage of it, because especially I use it in my work, let's say. I will not tell that I use it every time, no, but I try to use it as often as possible, and I really like it, because I don't like this approach when you add some implementation. After that, you try to think, okay, I should add some tests. You like write it somehow, and I see these tests which are not test anything. In fact, I have seen it so many times that I don't know. I don't like it really. Okay, so next maybe, doesn't this just make coders spend more time building tests than actual working code? No, I don't think so, because here using test-driven development approach, you prepare both, right? Same time, code, I mean tests and code, right? Because usually when you work on enterprise projects, right, which are long running, long living, when many people work on the same project, anyway, you will spend a lot of time preparing tests. So you will not able to avoid writing tests. Probably, you will spend a bit more time at the beginning, to establish what I have shown, all these custom mocks and so on. But in future, I think when you constantly use this approach, when you add more features, you will add it, you will do your development, implementation plus unit tests, because in my opinion, unit tests are part of the development, right? After some time, you will do this development even faster, in my opinion, than using, let's say, standard approach. So I think that test-driven development is really useful for long-running projects. Of course, if you need to do just some proof of concept, that you'd like just to check that this will work, right? And no one will use this code after, at least as it is. In this case, of course, probably test-driven development is not the best approach. Okay. Where do you draw the line between what you have to specify and what the developer will cover with test-driven development by himself? Where do you draw the line between what you have to specify and what the developer will cover? You mean, so I understand this question as following, that what should be provided in requirements, right? and what you should understand from these requirements, and which are like kind of these small technical requirements, right? I have provided in my code in comments, right? Because usually you have some BRD where you have some like general, let's say, functional requirements, and you should somehow translate it, right, to your small requirements for your unit. Well, where do you draw the line? Well, I would say this is preparing these small requirements. It is part of development, right? So this is for developer work. So you have some general requirements that, okay, your endpoint should return something if like should behave somehow what is defined in BRD. But anyway, when you develop your code, right, you should think that, okay, how you will do this? I should use some database. Okay, if I have something in, let's say, if I have entity in the database, I will do something. If I have like some values, I will send request. Anyway, you think about it when you write your code, even if you start with implementation, not with the test, right? You anyway will think about it. But here it is rather a question of sequence. So here with test-driven development approach, you should first think very well about how your unit should behave, and write it down. Like if this, it will do this. If something happens, it will do this, and so on. After that, you describe it with tests, and only after that you will implement these requirements. So in this case, you will think better about requirements. Probably you will even think better about your design. At least you will not add code which is not needed. So, like Yagni principle will be applied anyway here. You aren't gonna need it, right? So, thank you very much for your attention. I hope this presentation was useful and interesting. So, thanks a lot. Bye.